Hello, everybody. So, finishing or continuing on with polynomials, we're going to have our third test this Friday. So, Friday, November 20th, our third test on polynomials. All right, so that means we're really close to finishing polynomials, and we've done a lot with them already. Now, we're going to focus on polynomials where the degree is 2 or higher. So we've spent a lot of time on quadratics. They're important. But now we're not only going to include quadratics, which is degree 2, but we could go higher, 3, 4, 5, etc. So here's our first example. This is a polynomial, a degree polynomial. Now this degree tells us a lot. Three things that we need to know. The degree is 7, so that means it has at most 6 turning points. So that means if we were to graph this, like this is a turning point. That's one turning point. Well, here's another turning point. You turn around. And here's yet another turning point. So 1, 2, 3. This has 3 turning points. But since it's a degree 7, it always has one at most one less than this turning points. So the degree is 7. It has at most 6 turning points. What else is important? So that's something we will practice and get kind of comfortable with. Another thing is 7 is an odd number. So the degree is odd. That means the end behavior of this is going to change. What does that mean? Well, if we were to graph this, it's not going to look like this. First of all, how many turning points do I have? 1, 2, 3, 4, 5. Okay, so that's 5 turning points. Remember, at most 6. So that's okay. But the end behavior, it's going down to the left. And way over here at this other end, it's going down to the right. So end behavior means the two ends. What's going on? Well, they're behaving in the same way. On the end on the left, the graph is going down. And on the end on the right, the graph is going down. So that can't be this graph because this has an odd degree. The end behavior will always change. So it could look something like this. See how now these two ends, the end on the left and the end on the right. On the left, it's going down. On the right, it's going up. So that's a change. Every time you have an odd degree, the end behavior changes. And then finally, zeros are important. Since the degree is 7, there could be 7 zeros out there. 7 unique zeros. There could be 6 unique zeros, and then like one of them is repeated. You can have repeated zeros, but the degree also will tell you the amount of zeros. So if we were to solve for this, we'd be looking for 7 answers. So 3 things. It's odd, so the end behavior changes. It happens to be 7, so if you subtract 1, you get 6. That's how many turning points there are at a maximum. And it tells you about the zeros. There's no way this has 8 zeros. It has 7, at the most 7 unique zeros. And then the leading coefficient tells us one important thing. It's about the end behavior. When you go to the right, since this is positive, it's going up. In general, the leading coefficient. So 4 was that leading coefficient. If the leading coefficient is positive, then the graph is going up to the right. If the leading coefficient is negative, then it's going down to the right. It's all about on the right-hand side. If the leading coefficient is positive, it's going up to the right. If it's negative, it's going down to the right. And if the degree is odd, then the end behavior will change. But if the degree is even, then the end behavior is the same. Well, let's practice. One more thing, something called relative maximums and relative minimums. These are y values. A relative maximum is a big y value. That it's so big, it's bigger than all the surrounding y values. Let me show you what I mean. Load in, load in, load in, load in, load in. All right, so here is a polynomial. And let's check it out. I don't know what, there's lots of things to notice. Maybe the turning point is first. So there's 1, 2, 3, 4 turning points. So the degree could be a 5, has to be at least a 5th degree. Because remember, the amount of turning points is always one less than a degree. Look at the end behavior to the right. To the right is going down. So that means our leading coefficient is negative since it's going down. And also the end behavior is changing. The end behavior goes down to the right and up to the left. So since our end behavior changes, our degree is odd. This is an odd degree polynomial. And how many zeros do I see? I see a 0 there. I see a 0 there, 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 and there. So that's 1, 2, 3, 4, 5. So I see 5 zeros. So that makes me think it's a degree 5. Degree 5 agrees with a lot of things. A 5th degree isn't 5 is an odd number, so that means the end behavior would change. And then remember how many turning points there were? 1, 2, 3, 4 turning points. So the amount of turning points is is always one less than the actual degree. The maximum amount of turning points, I should say. All right, and let's end with practicing with Desmos. So here's a polynomial, and it's asking for the degree, the leading coefficient. There are blank zeros and relative extreme values. Okay. So, I forgot to go over one quick thing: the y values. So here, there's a relative maximum right here. This y value is 36.1. That's a big y value. It's bigger than all these y values, 27, 25, etc., and it's bigger than these y values. So in this general area, 36.111 is the biggest y value, but it's only relative to this area because this y value is 48. That's bigger than 36. So 36 isn't the biggest y value, it's just relatively big. It's relatively big compared to all these other y values. Same thing with this. So this function has two relative maximums, 36 and 22. It also has two relative minimums, negative 82 and negative 65. Negative 82 is really low. It's lower than negative 71. It's lower than negative 65. But it's not the lowest because this y value right here is negative 113. That's lower than negative 82. But this y value is the least y value in this area relative to this area. So this is a relative minimum. And relative minimums and relative maximums are in general called relative extrema. Okay, so delta math. Let's practice. The degree, what are my choices? Odd or even? Well, look at the end behavior. It's changing. Which one does it change? The odd ones. This has to be an odd degree because it's going up to the left and down to the right. The leading coefficient is positive or negative. Well, check, it's going down to the right. So if it's going down to the right, it's negative leading coefficient. If it's going up to the right, it would be a positive leading coefficient. So this is negative. And there are blank real zeros. The real zeros are x-intercepts. So I've got 1, 2, 3, 4, 5 x-intercepts. That means there are 5 real zeros. And how many relative extreme values? So they mean extreme y values. So here's an extreme y value right down there. That's a relative minimum. This is an extreme y value, a relative maximum. Here's another relative minimum, and here's another relative maximum, these y values. So there was 1, 2, 3, 4. And then it shows us, and the delta does a great job of just describing all these solutions. Let's try to do a couple more. Okay. So now this one, look at the end behavior. It's the same. It's going down to the left, down to the right. They're the same. So that means the degree has to be even. What's the leading coefficient, positive or negative? Well, it's going down to the right. So the leading coefficient is negative. How many real zeros are there? Well, I've got one right here, and one right here. So 3, wonder if it's going to accept that. Because what we're going to learn later, guys, is that you see how sometimes when it's an x-intercept, it passes through the x-axis. And at this time, it doesn't pass through, but it's tangent. So that means that a 0 is repeated right here. We're going to learn that actually tomorrow. There's a 0 is repeated. So I'm wondering what delta math is going to allow us. Relative minimum. Relative minimum. There's only one relative minimum value. Let's see here. And let's see what it says. Whoops. Submit my answer. Okay. And behavior, they're pointed in the same direction, so it's even. Let's do one more. Maybe two more. See if we can escape with two more. Oops. Okay. So I've got another polynomial. And what do you notice first? I notice that end behavior is different. It's going up to the left, down to the right. So degree is odd. It's again, this is our third one. It's going down to the right. So the leading coefficient is negative. How many real zeros are there? In other words, how many x-intercepts are there? One right here, only one. So it's just touches one, it passes through. One right here and one right here. So 3 real zeros. And a relative maximum it's asking for. So there's definitely a maximum right here. And there isn't quite one right here. This is called an inflection point. A relative maximum or a relative minimum, you will always be turning around. There will always be a 180-degree turn. You're going up, and then now suddenly you're going down. You turned around. And here, you're going down, and suddenly you're going up. You turned around. So this is a relative minimum. This is a relative maximum. What's this? Well, you're going up, and you still continue to go up, don't you? You never turned around. So this is not a relative maximum. This is what's called an inflection point. But there's only one relative maximum. And let's do one that has a leading coefficient that's positive, for goodness sake. Here we go. Hallelujah. Okay. And behavior is changing. So odd degree. Leading coefficient. Now this one's going up to the right. So the leading coefficient is positive. How many real zeros are there? You tell me. 1, 2, 3. 3 x-intercepts, so 3 real zeros. How many relative minimums are there? Well, a y value, a relative minimum right here. This is a relative maximum. This is a relative minimum. Whatever that y value is, relative minimum. And here's another one, relative minimum. So there are 2 relative minimums. Why not? Let's just do one more. Okay. What do I got here? The degree is even because they're both going in the same direction, up to the left and also up to the right. It only happens in even degrees. The leading coefficient is, well, it's all about the right-hand side. On the right-hand side, it's going up. So the leading coefficient is positive. And how many real zeros are there? How many x-intercepts are there? One right here, one right here, one right here. So that's 3. Relative minimums. Well, I see one obvious one right here. This is actually the minimum. Whatever y value is down here, that is the minimum. There is no other y value below this y value. And this is a relative minimum. So I'm not sure if they're going to accept this or not. I think they should accept 2, but this is a relative minimum for sure. This y value right here is less than all the y values around it. This y value right here is also less than all the y values around it. But this y value actually happens to be the absolute minimum. On this function, there is no other y value that goes below that. Let's see if they take that. Yeah, okay. All right, well, good luck, everybody. The homework is this assignment, and we'll see you tomorrow.